On behalf of 24houranswers.com, I welcome you to today's lesson. In this video, we're going to look at one example of evaluating a definite integral, and this will be a polynomial example. As you can see right here, we do have a quadratic. And then what we're going to do at the end is we're going to go graph this function on the TI-84, and I will show you how we can get the same answer by graphing it and looking at the area between the curve and the x-axis. So we want to integrate this polynomial here, and the antiderivative of 3x squared, that's going to be 3x to the third over 3. All I'm doing there is adding 1 to the exponent, and then I'm dividing by that same number. Same thing here, we have minus 5x to the second when we integrate, and the reason why it's to the second power is because we're adding 1 and we divide by that same number. And then be careful here with this constant. Minus 7 is the same thing as minus 7x to the 0 power. So when we integrate this, we have minus 7x to the first over 1. Of course, you can leave off that 1 and that 1 there as well. Now, with a definite integral, we want to make sure we come back and use our bounds from 2 to 3. And the way we do this is we plug 3 into all of these spots for x. And then we come back and plug 2 into all of these x spots, and we find the difference between those. But before I do that, I'm going to cancel out those 3. So we have x cubed minus 5 halves x squared minus 7x. And again, we're going from 2 to 3. So let's take 3, let's plug it into all of these x's that we have here. So when we use this 3 cubed is 27, minus 5 halves times 9 x squared, so we're plugging in our 3, minus 21 when we plug 3 into there. This is what we get when we plug 3 into this antiderivative, and now let's repeat this process for 2. So 2 cubed, that's 8, minus 5 halves times 4. I got the 4 there by squaring the 2, and then we plug in the 2 here, we have minus 14. So we've plugged in the 3, we've plugged in the 2, we want to evaluate these, and then we want to find the difference between them, and that will be our definite integral. That'll be the answer to our problem. So all I've done here is I took the 9 times the 5 to get 45 over 2. I left the 27 and that 21, I just brought them on down. Same thing for the 8. Be careful here. So we have 5 times 4 is 20 divided by 2 gives us 10. Then I brought down that 14. 27 minus 21 gives you the 6, bringing that on down, and then we have minus 8 minus 10 minus 14, that's a negative 16. 6 plus 16 gives us 22, minus 45 over 2, and now I'll finally get a common denominator of 2. So if we take 44 and divide it by 2, that will give us the same thing as 22, minus 45 halves, we get a final answer of negative 1/2. So let's double check this on the calculator. I'm typing in that original polynomial into y equals, and let's go ahead and look at this on the graph. I'm going to zoom 6. There's our quadratic, and notice our answer is negative. And the reason why our answer is going to be negative is because we're going to have more area below the x-axis versus above the x-axis when we integrate from 2 to 3. Let's go to second, trace. Let's find the definite integral, number 7. Our lower limit was 2. Our upper limit was 3. And notice we have this, what looks like a triangle. Technically it's not, but this area here is more than this area here. And when you have an area below the x-axis, we consider that to be negative. So since we have more negative area than we do positive area, that's why we have a negative answer. And as you can see here, we do get the same answer as what we got using pencil and paper techniques. And there you have it, a definite integral with a polynomial. We will see other examples where we may use trigonometric expressions, and there's tons of other techniques for integration coming up in the near future. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.